In this lesson, we're looking at reviewing domain and range. Domain is simply the possible x values for a graph, function, or relation. Now, sometimes this will be stated and sometimes this will be implied. So, for example, stated could be in the form of a set of ordered pairs. So we've got 1, 1, 2, 2, and 3, 4. So a domain in this case would simply just be x is an element of, and the values are simply discrete values. It could be 1, it could be 2, or it could be 3. So that's stated and discrete. The x values are 1, 2, and 3. Now, if we take something else like y is equal to x plus 3, where x is an element between 0 and 5, this is another stated. So it actually tells us straight away what the domain is. It's saying that for this particular graph, we're just going to look at graphing between 0 and 5 inclusive. So this is a stated domain. So this one's really nice and easy for us. We just have to say, well, our domain is x is an element of 0 to 5. Okay, so that's what we're looking at. It's either going to be stated or it's going to be implied. So implied's a little bit more challenging. If we don't have a stated domain and it's a type of function where we can see no issues, so let's have a look at, again, our y is equal to x plus 3. Let's say we're just looking at that. Now, what we have to think about is, for this x value, is there any x value that we can't sub into that? So is there any x value that if we put it in, we can't get an answer? And if the answer is no, they all work, then the implied domain in this scenario is that x could be anything. So x is an element of all real numbers. Now, the flip side of this is that if there is a scenario where x can't be certain values, so let's look at y is equal to square root of x plus 9. Now, because this is a square root, we should be able to determine that there's some values that just won't work here. So with a square root, if it's negative, then there's not going to be a real solution. If x is less than negative 9, then this is going to be no real solution, and that's going to break our scenario. So that tells us, with this implied domain, that x is an element of, our smallest possible value is negative 9, because if we put in negative 9, we get 0, and that's okay. And our biggest possible value, obviously, is unlimited. We can go up to positive infinity. All right, so a stated domain is nice and easy. Implied domain is a little bit harder. We have to think about the problem and consider the values that we could possibly insert into that function or relation. Now, range is simply then the possible y values for the graph, relation, or function. So now we're looking at those limits to the y values. Now, generally, with range, we'll have to work it out ourselves. So most of these are implied, or at least we're trying to calculate range values. So all must be considered or calculated. All right. So a couple of simple examples here. We're just looking at the y values. So the first one, we'll look at y is equal to x plus 3, and we'll give it a set domain. X is an element of 0 through to 5. Now, we can use our graphics calculator to graph this out, and we will. I'll talk about it as well. So we'll turn this one off. We'll deselect it. We've got x plus 3, and we'll go comma. We can put in a square bracket, and we want to go between 0 and 5, and we can put in another square bracket, put that in, and we can sketch it. So we'll just view window, we'll change it back to standard. Look, there it is. So we can already see straight away that the domain, the x values, only go between 0 and 5, so that follows what we want. With the y values, we want to look at what the smallest y value is and what the largest y value is. So the two ways we can do that is we can sub some values in, or we can look at the graph and work from there. So if we draw this graph that we've got up, I know when I sub in 0, I get an answer of 3. So this lower value is going to be 0, 3. And I know when I sub in 5, I get an answer of 8. So this upper value here is 5, 8. So there's our graph. We could also use trace to do that. So you can see there 0, 3. And when I sub in 5, I get 5, 8. So the smallest y value is 3. And the largest y value is 8. So that means my range is going to be y is an element. Now it's y is an element because we're looking at the y values. The smallest value is 3 inclusive. And our largest value is 8 inclusive. So there's our range, our limits in our y values. All right, sometimes it's a little bit more complex than that, but we'll look at a couple of examples now and hopefully we'll see that pop up. So for each of these, we're looking at the domain and range and whether it's a function or not. So for each x value, and here's our problem here, we've got 2, 0 and 2, 3. So if we did graph that, we get 2 points above. So we know it's not a function, and our domain will just be the x values that are included. So we've got 1. We don't have to put 2 twice. So 1, 2, and 5. So you can't repeat values in sets. And with our range, we'll look at the y values. So y is an element. And our y values are, the smallest one is -1. And then we've got 0 and 3 and 4. So nice and easy, there's our domain, there's our range, not a function. The second one, we can see straight away that it is a function because it would pass that vertical line test. We can draw a vertical line at any point and it's only going to intersect 1. So it's a many-to-one function. Now our domain, because these arrows here, it continues on forever, which means we're going to have every possible x value included. So our domain is x is an element of all real numbers, and our range is a little bit different. So we know that can be any value up to positive infinity. That's where we're heading off to. But the lowest y value we can get is -2. So y is an element of -2 is our lowest value, and we're going up to positive infinity. And next one is a many-to-many. So as soon as we see that it's a many-to-many, then we know that it's not a function. And we can look at our domain, and we can see there's only a graph between -1 and 3 in x. So x is an element between -1 and 3 inclusive. And range, y is an element. And our lower value is -2, and our upper value is 2. So y is an element between -2 and 2 inclusive. Now our final one's in set notation. So we're saying we've got a set of ordered pairs, and to calculate y, we use for take x cubed. Now if we don't know what that looks like, we can use our graphics calculator again. So we'll turn this fella off. We'll put this one in. So we've got 4 take x cubed. And there's our graph, so we can draw this one in. Now as soon as we see this, we can see that it is a 1-to-1 relation, which makes it a function. There's only one y value for each x value, so that's good. Our domain, we can see that continues on. Now, we can see that there's no x value that exists, so we can't sub into that. There's nothing that's impossible there. We can choose a large number or a very negative number and it still works. So in this case, x will be an element of all real numbers. With our range, we can see that that's continuing up to positive infinity, and this is continuing down to negative infinity. So the range will also be any possible value. So y is an element of all real numbers as well. Okay, so again, this is something that takes practice. We want to use our graphics calculator. We want to think. We want to go, is there any value we can't sub in? And we'll get better and better at this as we continue to do it over the next 2 years. Our final question is a little bit harder. We're looking to sketch the graph, state the domain and range using interval notation, but we're going to have to consider an implied domain, okay, because it doesn't tell us. So this first one, straight away, it's the perfect example for us because we already looked at one of these. We know that square roots are impossible when they become negative. So that means that anything less than 1, so x must be greater than or equal to 1 for this to work. If it's 0 or it's negative, then we get a negative number, and that's impossible. So we'll put this in, we'll graph it. We'll graph this, and we'll look at square root of x take 1. So we know that's our inverse parabola. We can see here, straight away, we can see the domain and range. It doesn't exist on the left-hand side, and it doesn't exist in the negative. So if we draw our little sketch here, and we go trace, let's put in 1 because we know that's the smallest possible value. Our value here is 1, 0, and there's our graph from there, x and y. From there, it's pretty easy to say that, okay, my x values, 1's the smallest value, and it goes up to positive infinity. So our domain is x is an element from 1 through to positive infinity in a circle bracket because non-inclusive. And our range, we can see the smallest value is 0, so y is an element. 0 is the smallest value. And we're increasing here as well, so we're going off to positive infinity in the range as well. When we look at the second one, we can graph that as well. So x squared take away 4. Now the cool thing here is that they give us a stated domain. So even without graphing this, and we'll set that up, x and y, we know that our domain already, because it's stated, is that x is an element between 0 and 4. So we don't care about anything else. We just care about those y values that come from the x values between 0 and 4. Square bracket 0, comma 4, and close our square bracket. And we'll draw that. And we can see straight away that, yep, it does stop. And we can trace, and we realize our smallest value is negative 4. So let's put that in, negative 4 here. We can find our x-intercept if we want to, so g solve root, and we get that's at 2, 0. Not important for domain and range, but important for sketching. And if we trace, and the biggest x value is 4, and we get 12 up here, so 4, 12. And there we go, there's our graph. We use the colored dots to end it. There's no arrow to continue. And our range is simply y as an element. The smallest value is negative 4. And the largest value is 12. Now these are both inclusive because the x values were inclusive. So there's our domain and range. Okay, so that concludes the lesson. I know there's a lot there, but it is a review. You'll need to make sure you work through the set in the next tab. And that will give you enough practice with all of this. Okay, thank you.